All right, for people joining this live stream, we are continuing our review of spatial statistics functionality, which is intended for the upcoming version of Wolfram language. And somebody who should be on mute isn't on mute. Okay, let's see, where were we at last time?
We had started going through this first section, and you just looked in on one of those homogeneity measures. We looked at intensity.
All right, so first of all, we need this spatial point data, which is, usually when we have a function whose name ends in data, it returns data. It doesn't represent.
Well, temporal data, represents data.
Okay, that's one example I know of. So that's an example, but
we have another one in travel directions data.
Okay.
Optimum flow data. But that's sort of a return.
So which one? I mean, so all right. Let's understand. Is there a future spatial region data?
Yeah. So there need to be, there's a different container for continuous data.
Well, but I'm asking a different question. I'm asking, let's say that the spatial data consists of the counties of blah and blah and blah.
There is potentially. So this is part of a bigger area called stochastic geometry, in which case you have random lines, random planes, other elements, basically.
Right.
And in principle, you have regions, collections of regions, like leaves, for instance, covering the ground. Or in the line case, paper is built out of lines, fibers.
Yes. Okay, but so what we're thinking about here, what this container represents is something that has been spatialized, just like a time series is, contextualized in time. This is contextualized in space.
Yeah.
Right? And in principle, the set of things here, so right now here, the set of things, which can be in any number of dimensions.
Yeah.
What is the analog of geographics for this?
I think if you just want the raw, I mean, I don't think that geographics has this notion of annotations. But if you just want a bunch of points, then geoposition is a multi-container as well.
No, I understand that. I'm asking the question, if I want to get from spatial point data, I just want to make so spatial point data is attach spatial coordinates to a piece of data, right? It is the analog of event series for.
It's sort of the other. I mean, you can very well have spatial point data without any annotations, any other data.
So you can have an event series without. What do you do with an event series where you just want to manipulate it using date histogram and so on?
Yeah, we didn't build it that way because really event series was supposed to be discrete time series, which is not the same as a truly event-oriented data that we named it as. But so it's a little bit misnamed. I think that's what we should redesign it for, because that's what it became through the design process.
Which?
To be like this, in the sense that it just maintains events with additional annotations, basically. And there's no way that you combine them in any particular way. But you can do temporal statistics on it and so on. You can have intent. So for instance, if you think of earthquakes, if you think events in time, you can very well talk about intensity functions over time. It's also the case that in the case of events over time, like the humanly collected data is often aggregated. So for instance, when you get traffic data, you often get traffic counts per 15-minute, hour, and so on, or people entering a store, you get sort of aggregated
So
data.
it's combination space and time. Potentially.
Potentially that can also happen potentially. But in the car counting data and stuff, that's it's sort of things in time.
Okay, but the main point
or server data.
Okay, so hold on. So what we've got here is we've got primitives that represent primitives that represent where, and we've got potentially and values that represent what.
Yeah.
And I think this should be an association by, I think it should be documented as an association here.
But it's, in which way do you mean?
This thing here should be documented as an association. The payload for the points should be documented.
I see what you're
saying.
Yeah, I think you're right. I think it should be.
Okay. Shall I just change it, or is somebody else? Who else is on this call?
Gosha's here. She's the one that's been.
I'm taking notes.
Okay. Okay. So it's where and what. Mm-hmm. So in the case of
it took us a long time to get to this. That it's annotations and hence associations. By the way, Stephen. So we went a long way around just to the history.
Okay. Fine. Okay. So I'm just to comment on this, okay? To me, it seems like the left-hand side, it's very much like a time series or an event series. And I can imagine that left-hand side could in principle have primitives in it that aren't, it can default when you just give a list of values that represents a point. But if you might give an actual line as that left-hand side, that is a symbolic representation of a line as the left-hand side, and say on that line, this is the payload, so to speak.
Yeah. I don't think that we can guarantee anything sort of in the evolution of that object.
What do you mean?
I think the best we could do is sort of, be a container that you can query things out.
But so let's just understand, if we use GeoRegionValuePlot, okay? GeoRegionValuePlot has, what is its form? What is its representation of?
I think it's just region, and those can be entities.
No, I know. GeoRegion. Oh God, this crazy thing with the streaming, whatever. By the way, who is taking notes here? Is that Gosha? Is it Avery? Who's taking? Or Andrea is taking general notes here. Could you please comment that when I type this in, this is the 12.2 prototype. Okay. First of all, I really don't think this is working right. This way that this. Do you see what I'm seeing here?
Yes,
do you understand
it's
what
like
I'm saying?
jumping.
Yes.
Yes.
So you should comment on that. The second thing is, once I have it, I can't click it. In other words, there's something wrong with the way selection works when I'm at this point.
Okay, I'm going to report that to the documentation soon.
Okay. All right. So here we've got a pattern, region arrow value, right?
Yeah.
Okay. So
then there need to be multi-values.
But by the way, does GeoRegionValuePlot now support region, which is now geoizable?
I don't know.
Okay, Jose, that
because the updates that are coming have to do with being able to. I forget why we do. No, I know why we're doing it. It was.
Okay, so look, the region, clearly. Okay, and also obviously GeoRegionValuePlot should somehow be able to eat spatial point data of some kind.
We have discussed that for geographics. Geographics will be able to take spatial point data and get the spatial information.
Good.
Data and show the
Good,
region.
but so Jose, you weren't saying anything when we were talking about whether GeoRegionValuePlot supports region on the left-hand side here.
I don't know for sure. That would be a question for Brett, but I don't think it does.
Okay, so that's a bug. So let's get it fixed.
Yep.
Right. Okay. So okay, but notice. All right. So what I keep on pointing out here is I don't think the word point is right here.
I mean, if the problem is when we make them very general, we can't really guarantee anything. They become.
Yeah, but that's the way it works. I mean, the fact is, this should become a container for arbitrary, spatially tagged data. And by the way, wait a minute, what is this? So this is a transpose of the way that this works here, right?
We need keys. There's no keys there. It's only a single value to begin with, right?
No, in this case there is, but I mean, we should obviously extend GeoRegionValuePlot to be consistent with this. But
Point
also
value plot. We have a new function called point value plot that does that.
Does what?
That allows for any number of values.
Where is it?
We looked at it in the visualization review meeting.
So in principle, we could consider having a function called region value plot, which isn't a GeoRegion value plot, right? So point value plot, does point value plot, it works for geodata, right?
Yes. Both geo and non-geo.
Right. So why don't we have a region value plot?
Yeah, we could probably
Okay.
add that.
Let's plan on that.
It needs some. Yeah,
I know it needs some thought, but okay. So then I'm coming back to, I mean, in that sort of family, I do understand spatial point data does make some sense to distinguish from general spatial data.
Yeah.
All right, for this version, okay, can we tag it as experimental for this version? Because I think we're going to want spatial data as a general thing going forward.
Yeah, I just want to make sure that you understand one, and I'm fine with it being experimental. I don't care particularly. But there's one thing that I just want to make sure you understand. Mm-hmm. This is discrete data. That there is no interpolation between the trees. You know, if the points. Okay. Yeah. Good.
Right.
There is another object that people want, which is something that's interpolated between them.
I understand, which has some kind of density, spatial density data.
Yeah, actually, when you derive the density, you get a field. So that's one of those continuous things.
I see. So it's spatial field data, effectively.
Yes.
Are we going to call it that?
I don't know. That was an interesting name.
I think it's not a bad name. I mean, in that way, what is the general category of thing? Points, lines, regions, that is, you know, what you have is where it is type thing, as opposed to the field.
Well, in visualization, we call them glyphs. Yeah, no, I know.
Hello, a tree is a glyph.
Yeah, no, of course not. The thing is that, you know, for the stochastic geometry side, I think that sort of the applications fall off pretty quickly from points, because points itself is pretty hard and everything else is not easier.
Yeah. Okay. Anyway, let's look at this function some more. Okay. So yeah. I'm getting sold on it being called spatial point data, and so then point value plot as well as list plot, right, works directly on this, right?
Yes.
But which one are you really promoting? Are you really promoting?
No, point value plot came in late, but that's what we're going to be promoting, because point value plot is sort of the universal kind of tool that works for.
Right, but point value plot then annotates the values with something, right?
Yes.
I think you should promote both of them.
I think we are. I mean, we
list
will.
plot is just like use the original.
Just use
values.
the points, yeah. And list point plot 3D for the 3D data.
Okay. This is useful. I hope it refers to. Yeah, don't forget to make this refer to GeoRegionValuePlot and vice versa.
Of course. So
And
this will
yeah.
there's as many this is going to be kind of rich, because often when you have, it's not hard to imagine, particularly with the entities that we have. Let's say a city is a point, but there's an awful lot of potential attributes.
Sure.
Or properties for a city that you might.
And how will those be converted from
data to visualization? So that's part of what that is modular.
Right. By the way, this dimensions. I hope
the
it
encoding
returns
layers for point value plot.
It returns. Wait a minute. Wait. I hope it. Roger, can you hear me?
Yes.
I hope dimensions returns the actual dimensions as I would think it is, not 2 or 3 or something.
What do you mean by that? What do you think?
What dimensions the function dimensions returns? What does dimensions mean here?
Yeah, that's a good question. I mean, it says dimensionality of point coordinates. So that's basically the length of those.
Well, is it? Gosha, can you say, please?
So yeah, so what we want to have the real world dimensions. So if your points are in 1D or 2D.
Okay,
or 3D,
so it's the wrong name for that. It's the wrong name, right? It's obviously the wrong name.
So that's should be dimension. I think that's what we put in the elided form.
Why doesn't this work?
Can you remove the S, please? Yes, so that's my bad of not updating the documentation.
Okay, that's fine.
Mm-hmm.
Point coordinates of the first configuration, what does that mean?
That means that configuration is basically like a set, so you can have multiple sets for the points.
I don't see that in this documentation.
It is the last input where it's actually with annotations. So this is how you input multiple point configurations.
But this isn't right. This isn't right. This isn't how you're doing this, right? Isn't it the case that it's point arrow value, point arrow value, point arrow value?
No. They all have keys. So you have a whole list of vals for each key, corresponding to the list of points.
So that's the transpose of GeoRegionValuePlot.
Because it's not really comparable. The points here are usually huge. Think of all the trees. Okay, you're going to have annotations for all the trees.
Wait. You have a transpose of what we should be doing here. We got to support both forms. Every machine learning function supports both forms. That's what we need to do here, and that's what we can do. Okay,
what do you mean by both forms? It's
okay. So here's what I mean. You've got something which says, you've got a list of points, PT1, PT2, etc.
Yes.
Goes to essentially val1, val2, right? That's
they have keys. They have to have keys.
Why? Why do they have to have keys?
I mean, they don't have to have keys. The key will be generated automatically if you do not specify the key.
How the heck are you going to figure out what that key is then? You have to go look it up then, right?
Right. It's going to be enumerated by integers.
But I don't understand. Why do you need keys?
To know
how else do you know
how to access your annotations, to know which.
Yeah, but most of your functions are saying mean intensity. Well,
yeah.
These are
our descriptive statistics. Our descriptive statistics doesn't look at the values. Okay.
Okay,
This
so
is in
none of this.
preparation.
Hold on.
But there is an extension to all this descriptive statistics that does work on the value domains too.
Okay, fine.
That
So
we
what I'm
haven't
saying is,
implemented.
I'm saying that what we've done in other functions is you can either have, list of points goes to list of values,
But
or
you
you
need the
can have.
keys too. So I don't know what you
I
mean by
understand. I
transpose.
understand. So we do this, right? That's what we do in every other function. Right? So every individual point can be handled separately like this.
Sure, that can be done. I mean, it's
Okay.
very inefficient, but it can be
I
done.
don't care. I don't care.
I know you don't
Maybe
care.
we've got
about,
20
I know you don't
points.
care about efficiency.
No. I don't care because you're wrong. It's inefficient when you have 10,000 points. But the issue is, can somebody understand what to do in an example where there are 10 points?
Sure, we can do it.
Okay. It's the same as what we've done with all the other functions. So then I don't know what we do in the case where, okay, so this is, I mean, look at how it works for something like classify, right? Classify has all these different cases, right? Example goes to class, and then list of examples goes to list of classes. See what I'm saying?
Mhm.
That's the kind of thing we need to do here.
Yeah, except we have 3 things instead of 2 things.
Because, well, you've also got just the list of points without their keys, without any
Yes.
values. So now the question that I'm asking is, I'm sure it's the case that there will be data sets where every point just has a particular value. The height of the tree. You don't care about 17 keys for, height and this and that and the other. You've just got data where there's one value for every point, right? And so that's why I'm suggesting this form be supported for that, where you don't have to give a key. But since I don't understand how you're doing the extraction yet, right? Gosha, you understand what I'm saying?
Yes, I do. It's just that exactly that's this way of inputting the annotations, it just seems very cumbersome if you have many points.
Of course it is.
And
of
most
course
of our
it is.
most of our data that we found in the world, it's
Wonderful.
it's
Terrific.
huge.
Okay,
And so
so
that
I'll
was just
invent for
super
you.
inefficient
Okay, so I'm going to give you
so.
points. Okay, why don't we list our company offices around the world? Okay, how many of them are there? Not very many. We can just list them like this. Great, thanks.
Mm-hmm.
Okay. So that wasn't the point I was addressing. The point I was addressing was this form here, right? Where you are merely given a single value for every point, where you don't have an association with keys and values for every point. Do you see what I'm saying?
Well, that's the input that it's understood.
No. Right now, you are insisting on having a key for every value. I'm saying you shouldn't do that. I'm asking you, is there a problem with that?
There's no problem with that. I explained it before that if you don't provide the keys will be generated automatically.
Okay,
in
but I'm
form
not
of
sure that
integers.
I'm not sure that makes sense, and we need to look through where you're using that fact, because I don't think that's going to work.
Well, you need to enumerate the values, the annotations in some way, because if you give multiple,
No.
maybe
But I'm saying
you can give
I'm
multiple
saying
information for each point.
No.
Yes.
No. You're not understanding my point. This about points. This form is just listing a single value for every point. Were I
Yes.
to list multiple values, yes, I will have keys and you'll know the name
Yes.
of each of those sub-values. What I'm saying is this is a case where there's just one value for each point. There's
Yes.
no automatically generated key. There's just one value.
Well, there is
Right.
a key.
Why?
Why not?
Because we don't need it. But
how
we have
do
to
you refer to that?
We'll have to look. We'll have to
what if you want
that.
to add some more, annotations? Then what?
But
how
then
do you
you're out of luck. Then this form isn't going to work for you. You're going to have to redo it, right? In other words, if you're going to take this data, if the data that you thought you had isn't the data you actually want to have, then absolutely you're going to have to go through. But generating an automatically generated key is completely crazy, right? In this case, what we've got, we've already had this example for machine learning for lots of other things where you can either have a value or you can have an association of keys and values, right? So let's look through where you're using the values to understand how you extract the values in these two cases. Make sense?
Sure.
It's not as crazy as, I'm not being as crazy as you're making it sound I'm being.
There's some
okay.
examples of that. If you want to look at the examples, then there's an annotation section.
Okay, so hold on. First thing we want to look at here, you've also got this thing. I mean, okay, it is a disease with you guys that you do the very complicated case and you don't do the simple case. So I'm dealing with the other end, right? I'm dealing with a stupid simple case and I want to make sure it works properly. And then we interpolate to get to the, the fancy complicated case. All right. This business about configurations, okay, what is a configuration?
It's a point pattern, so it's a collection of points. We don't call them point patterns, but that's what they're usually called in the literature. That's
okay.
the object that you call. You don't study individual points, you study point patterns.
No,
and you
I understand. I understand.
And you need several of them. If you're going to derive statistics, you have a model that generates those. You need to deal with the collection of all possible forests.
So this is the mistake of temporal data versus time series.
Yeah, this is the temporal data version. That's the thing that's needed for the models and the data to go together.
No, it's not what's needed. There's plenty to be done by just having the map of one forest. Having the map of multiple forests is a different, more complicated case. This is this case here, right?
Yes.
Yes.
Okay, so let's make sure we don't confuse everybody. Why don't I start editing this? Okay, look, I think this should say represents a collection of spatial points with positions I would personally do it, since that is a list.
We're going to use, in the rest of the literature here, we use configuration though, as a concept.
Okay, I don't think it's a great concept. I think we've got to start simple and we got to talk about a collection of spatial points. That's what the everyday person knows.
Sure.
Yes, the 6 experts in this call them configurations, but
no, they call them patterns.
Okay, then let's call them. Let's have that mapping. Okay, I don't think configuration is a good name. I mean, I think it's not a name. I mean, I don't see what's wrong with just a collection of spatial points. Now in this case, is there a reason why you don't say PT1, PT2, etc. here?
Yes, because also could be a geoposition.
Because exactly. They can be geoposition. They can be geoposition X, Y, Z.
Right. That's okay. But I mean, just PT1 with positions of spatial points with positions.
But the positions are described below. We took all that out to not get an unreasonable box up there.
No, but I understand. But you don't have to describe it. Specified by PT1, PT2, ... Because that way you're saying to people what the form of this thing is here.
No, but geoposition have them inside of itself. It doesn't have point 1, point 2.
We have a little table in the notes that explains the form of
fair
points.
point. Fair point. That's okay. 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 Look, represents a collection of spatial points. And is it constrained to be? What is the observation region? What do you mean observation region?
Within this region, we found all the points of this type, all the bird's nests, all the insects, all the trees, whatever it is that you study, all the earthquakes, meaning that if there is no point in this part of the region, it really was none.
The region is also to tell you that, for example, some part of the region of interest might be devoid of points.
Yeah, that's
And
what
you would
No,
not
I
know it
understand.
if you just give the points. Yes, and
I
also
understand.
the issue is that here, if you give points and the region, the points which are outside of the region will be discarded in the
fine.
creation of
Okay,
the.
why don't we say with bounding region reg?
No, don't do that.
Because it's always called observation region, I think, in literature. So
look, it's okay. Look, there is a literature, there is a specialized field that calls these things point patterns, right? There's a specialized field that has a bunch of names. I'm trying to get it so that we're not talking about observation.
But bounding region has a very specific meaning for us. We have geobounds. We have all kinds of bounding regions.
Okay, well, so is this not a bounding region in that sense?
No.
Okay,
I mean,
why
it
not?
is. There is much smaller bounding regions, and if you say bounding region, we think that it's one of those smaller ones.
What do you mean by smaller?
If you
Why isn't this okay? When you say bounding region, normally it's like a plot range. There can be points outside of the plot range, but we're only considering the ones inside the plot range.
Yeah, I mean, as I say, it's significant that there are empty parts in there. Okay, but the bounding region can usually be much smaller. And if you write bounding region that we use for so many other things.
What do you mean by smaller? I don't understand what you're meaning by the word smaller. You mean smaller in physical size or smaller in concept?
Smaller in physical size.
Okay, but so what are we going to say? Because
in which case you get
the notion of observations is that is assuming a use case for these points that we do not need to assume. You see what I'm saying?
It does.
So let's not assume that. Let's just okay, so how do we characterize this region without saying observation? Assume to be within the region reg or something, or just within the region reg.
That's also
no, there's a whole reference entry for observation region Q.
Okay, what do you mean? What I don't understand.
Maybe it's not listed.
It's
on the guide pages. It's listed.
It's the observation region needs to satisfy conditions.
Okay, like what? Well, it isn't found, so it's not there. Well, that's a really weird thing to have.
It's spatial observation region Q.
Okay.
If you scroll down a bit on the spatial point data, you can click on there because it's listed there.
Oh, God.
Yeah, they're often called windows.
But windows then appear in a filtering, domain in Wolfram language, so it would not be the good name.
None of these. Look, come on, guys, come on. Okay. Look, let's not make the mistake. Yes, there is an existing field that uses this stuff by experts with expert terminology. The goal is to have this so it's actually usable by people who don't know all that expert terminology. So I don't think this is going to cut it, right? I don't understand. Can be an observation in spatial statistics? What the heck? You mean an observation region or something?
Yes. But
this isn't, you see, there's no statistics needed here. We've got lots of things here that are barely what anybody would call statistics. Making a histogram, a point intensity histogram, is hardly, yes, of course it is statistics in some sense. But, okay, what are we going to call this? Because this is, what you're saying is, this is the region. I personally think at this level, the documentation should just say within the region reg. Because I think that's what, you see what I'm saying? Because I think that's enough to say here. You can explain how that region is being used later. Because that lets people understand roughly what's going on. I mean, observation region is just like, nobody's going to understand that. except the 6 experts. But let's keep going here. So the next thing we have is the use case of so now you've got something which says points, points arrow vals, ... Right? That's the case where you know, associates the values vals with the positions points. Is that right?
Yes.
Okay, so then the next case we have here is this case here, right? The next case we have, and then this one here should be, say, something like okay, so how do we disambiguate that from the case where we have an individual? I see. So this is the next case here is PT1 arrow data 1, right? PT2 arrow data 2, etc., right? Is that right? That's the transpose case, right?
What's data?
Well, either value or an association.
Okay.
And then the final case.
Shouldn't you write that out a little bit more detail so you can see that then?
Well, I will say it here.
Okay.
I mean, but the final case here is multiple collections represents. Now, if you have multiple collections of points, how do you deal with that? Is it spatial data, points 1, points 2, etc.? Did you understand what I'm saying?
Do you mean access it or?
No. Specify it, right? Do you understand what I'm saying? There are multiple collections of points. There are 2 types of trees, right? And you have their positions.
Yeah, you put
Well, you
the
don't.
list.
I mean,
Right,
that's annotation.
not everybody is. No, it's not an annotation. You just told me that you've got this notion of collections, right? Or what you're calling
Right. So you put the list points 1, comma
okay,
points 2.
You didn't document that.
Because we documented with annotations. So if you remove that from the picture, you get exactly the list.
But you don't do it with annotations because you didn't have it with annotations, right? The annotations are something different, right? This is what you're saying. Okay, so this represents multiple collections of spatial points, right? And then you have this case where you've got multiple collections of spatial points with annotations, I think. Okay, let's keep going and understand how this works now. Okay, so now here, so I don't see any problem with calling this. If you insist on calling it observation region, I still think it's weird, but it's okay. I mean, I think you could just call it region here. And this does not make sense. I don't know what we call it this because we haven't really had that in the case of list plot, for example. What do we call those multiple, when list plot has multiple data sets? We call them data sets usually in our informal documentation, at least.
Yeah.
Right. Although that now has a technical meaning for us.
I think we just removed the name data sets and called them data 1, data 2. So.
No, I understand that. But in this access, this is crazy. I'm sorry. This is no, absolutely not. I mean, okay. Look, what you're trying to do is you're trying to hack the fact that the design allows you to both have the thing not in a list and the thing in a list, and multiple things in a list, right? That's why you've got these two different things here, right?
Well, yes, because you want, if you have just one observation set, you want to have easy accessors that make sense.
I know.
In a sense, like we have with temporal data, that we have path, and or values, and then we have values list. If we have multiple paths in temporal data.
Let's not use temporal data as an example of design prowess, because temporal data, made the same mistake that you guys are about to make here, which is it's a very complicated thing that is of relevance to experts, but the actual use case that people want is a single path time series 98% of the time. And that wasn't made easy to do and involved all this weird stuff with paths and so on. And let's not make that mistake again. The generic case has to work with so I understand you've got this issue here of
how to distinguish. Yeah.
Okay, we can deal with that. Let's understand what we're trying to do first. Okay. So all right. So let's see. So we've got now people on live stream are wonderfully confused about some of these things, like speculating the configuration is a schema. No, it's not. That's what's confusing. It's just a collection of points. It's not the schema for a configuration you might reasonably think would be something like the collection of keys and so on, but it isn't. Yeah, there's a complaint from somebody about time series. We're working on it, I hope. Let's just look at a few of these live streams. Steve is suggesting that we reward regular attendees who made great suggestions here in some way. And yes, that's a very fine idea. And I think we've had the right way to do that is conferences and things like this. That's I think the right and the beta test program and so on. And it's a good suggestion, and somebody should look into that. Okay, which graphs can take spatial point data and display it along with the annotation? So I guess what Brian is asking there is which things like list plot can you feed this thing to? What's the answer to that?
So we've made an initial list, and we've made it work in a lot of them.
Okay.
Like bubble chart, list plot, list point plot, 3D of existing. Which other existing ones, Gosha?
I mean the list plot and list plot 3D, but in this way you only see points. And
point value plot is the one when you really want to see the attributes.
Right. So the point value plot is really the thing that takes
I
the
understand,
value.
But can I just clarify for you guys again, right? That you are thinking of the very complicated case where people have 100,000 data points, 7 different, whatevers in 7 different collections with 18 attributes each, right? But there is also a case where they just have the map of 100 trees and they just have their positions, and we want that to work nicely,
right? So
without people having to. So
yes, so we want this to be supported into the list plot and then the list point plot 3D, and that just only takes the locations and it will just print you a points representing.
But what about list plot 3D, for example?
Because it connects.
No, it's a surface.
Yes,
I understand, but in the case, but look, in this case where we have points and values, we can perfectly well show those values as heights in list plot 3D. Just like, for example, a surveyor went out and got elevation data and fed them into spatial point data.
Right. If you
Can.
know that these are
So what we
reals.
haven't really built a type system for the values,
Right.
but you know, so for instance, let's say that the value there is birch and pine.
Fine, then it's a different issue, right? But in the case where if you feed that in to, you know, list plot 3D, it's not going to work. And but I think we should make it so that in the case where, you know, just as list plot 3D takes point arrow value, I think takes point arrow value input, so this can, so you should be able to feed from here to list point plot 3D, list plot 3D.
Yeah.
Okay.
I think we can. I mean, after this release, we can make that work.
Fine.
And we can.
Okay. So let's go back down here. This is going to take a while longer. Let me just look at the calendar here. Oh my gosh, we're supposed to do geography and dates live stream in a moment. Why don't we ask the soon? Why don't we ask the people who were in that to join this meeting? It's an overlapping group. And also don't think it'd be bad to have Brett and these other guys here. So if we can just ask them, can we do that, please?
Yes.
Thank you.
I'll talk to him.
Okay, Luis is commenting, spatial statistics functionality will be useful to help devise policy measures concerning mobility in smart cities. Yes. Okay, Sandra is asking, can we get local density somehow? In fluid dynamics, one generally finds local density by being the inverse of the area of the associated Voronoi cell.
It's point intensity.
Yes.
Is that what it is?
Yeah,
Yes, there's an
yes.
implementation that uses that as well. The method, yes.
So if I were to take okay, so let's say I say, why are we bothering to give the region? I see you're giving that region there, right? So let's pick this
because
out.
it creates different region if you don't provide the region, so you get a different spatial point data. You know,
Yeah, I get it.
even for the same set of points.
I get it. Okay, so that isn't right. That should have just been the summary blob, right?
Is that prototype?
Yes. Gosha, what are you going to say?
Well, I will not say that probably what you have is the outdated documentation, and therefore your prototype build might be ahead of it. And so I would suggest to recreate the spatial point data example.
No problem. No, now it beeped. And for some reason, though, this wasn't fixed. Andrea, can you please ask to make sure somebody figures out the bug that is causing messages to be put in a separate window on my machine? I thought I had asked for that really to get fixed.
Okay, I'm going to tell that to Roger and the people. Okay.
Yeah, it'll be for the 5th time, roughly. So tell them to put it in the meeting that I have this afternoon to fix some other things that have been trailing. That one needs to be there too. Okay, so spatial point data, point thread. So this is just a bug here. This is not working, right? It's just an internal bug, right? Yes, Gosha?
I think so, because that worked for me earlier. So I don't know.
No problem.
Yeah.
All right. Okay. I just want to get some example here so that I can play with things. Okay, looked like the region didn't work there. Okay.
Mm-hmm.
Okay, so now what is this? Okay, so that's
so
type Delaunay.
Delaunay. If you would like Voronoi, then you need to put point intensity, your data, comma, string Voronoi.
Okay, terrific.
So Delaunay, it's a linear interpolation.
That was a much easier answer, I think, than Sander was expecting. But okay, so now what do I do with this point intensity function? How do I plot it?
So it is based on the locations. So now you are in 2D, so you can use plotting that would plot this as a function of 2 arguments.
I'm guessing it's going to take a list of
yes
points.
It's a location, so it's a vector xy in the argument.
Okay, what's the range of values? I think I said.
So x is, we are in a disk of 0, 1.
Okay.
4. Like 4, radius 4.
Oh, radius
4.
Radius
Sorry.
4. Yeah.
And it's centered at 0, 1.
Sorry, my bad. I work too much in the unit disks. Yes.
Okay, not bad. Nice, actually, very nice. So if I were
that
to
intensity will be pretty constant because you use random points.
Absolutely, yeah. Why is that beeping? Why is it beeping?
Plot 3D, probably.
Oh, yeah. Silly me. Okay, fine. All right, so now why isn't this... Those are Voronoi. That isn't smoothed in any way.
No.
So those are the raw... So if I were to take fewer points here, okay,
yes, you're gonna get coarser mesh because it's based on the point locations.
Okay, what's that picture there?
That's the illustration for the intensity.
No, I understand, but why is it in a square box like that? Okay, so this is now, so I don't really understand what happened here. So I would have expected this to have Voronoi regions that show the intensity. I'm now confused how this is working. Did you understand my question?
Did you want to use Voronoi?
Well, I don't like Voronoi. I don't care. Isn't it the same type of thing that I should get here? I can use Voronoi just for the sake of using Voronoi, but I don't understand why it doesn't have discrete. Is that what I'm supposed to do?
Yeah.
Okay. Well, that's not working. Okay, but in any case, I don't understand this. I don't understand that box, and then I don't understand why this is not showing in the Delaunay triangulation. Why is it showing these smooth pieces, or am I wrong that it's smooth pieces? Are they really piecewise?
No, they're piecewise linear.
Yes.
Okay.
That's why, if you wanted it constant, that's why you needed to specify Voronoi.
Oh, okay. But if I do this, for example, I should see these things have flat. Is that right? Is that what you expect?
Yeah.
Okay.
Piecewise linear.
Why is the cookie cutter so jagged here, given that there are very few points? Do you understand my question? Is that just a question of the adaptive plotting in Plot 3D?
I think that's the adaptive
Yes.
plotting.
But so your function there is, oh yeah, beautiful, magnificent. Great, that's exactly what I expected. I mean, give or take. Might even be a useful example. Maybe you already have one like this. Do you have an example like this? Do you have an example like this?
I don't think we do, no.
Okay, so there you have it. Okay. Could whoever's making that clicking noise please put themselves on mute? Okay. Complaint about discrete and continuous distinction in the data. I don't understand that one. Okay. Ethan is saying he wishes that spatial point data of points comma values worked. I think that's I think the correct ask there is points arrow values, which will work. Sander is asking the same question I was asking. Why call these things configurations? Yeah.
Configuration was as an alternative name to pattern.
Right. I think collection is a fine name. I mean, okay. Ethan is commenting it's having to use thread.
So can I comment on the collection versus configuration?
Yes.
Because collection for me means that you just have, points in an unorganized manner. And configuration actually means that you pay attention to where the points are located. Collection, you can just put things into a bag and you don't care how they.
No, but that's what we're saying. Exactly. We're saying
we care. We
collection
care how
of spatial
located.
points. That's what we're saying. A collection of spatial points. It's not the fact that it's a configuration. It's a collection of points, and points by their nature have coordinates.
Okay.
I think it's going to work, Kosha.
Yeah,
I mean, there was a reason. I know we considered collection.
Yeah.
And I can't remember exactly why we rejected it, but there was many iterations there.
Yeah.
Okay. All right. Okay. So let's go back down to this. This question, this comment of Ethan's about threading here. Let's take a look at this. This is probably a different. All right. So let's take a look here. We've got.
That's covered by the overhaul of GeoRegionValuePlot in 12.2.
So this is fixed. Is what you're
will
saying.
be once the branch merges.
Okay, so samples arrow heights will work. There's no need for a thread.
Correct.
Great. Okay, that was a good answer. Okay. Okay. Ethan is commenting on, please make the automatic plot points option in plot smarter. That is a good suggestion after all these years. Maybe worth looking at, Brett. I don't think we've looked at that in years.
Do we have a definition on smarter?
Well,
no, but it's a valid point. I mean, I think that we can actually.
Yeah, I mean, every few versions we up these plot point values because computers have gotten faster and things like this.
We haven't really upped them very much, So I think that we can use more resources. If Moore's law is true, we should be able to use more resources.
Yeah, but Moore's law died 10 years ago.
I was going to say Moore's law isn't true.
No, Intel still believes it's true. So we believe it's true.
All right. Okay. Well, if they're engineers,
I was going to say, I think I saw a headline a couple of weeks ago about Moore's law being replaced by something. I don't remember what the something was.
Oh, don't tell me. It's.
Oh, it was Huang's law. It's the NVIDIA law. It's Huang who's able to do that for GPUs.
That's funny. Okay. All right. Let's take a look here. So what you're now saying is, so we've got these right, great. Okay, geo regions. All right, fine. So for example, if I were to say here, just to understand how this works, if I were to say, let's say, state capitals in the US. Okay, and now I just say, see, I'm being spatial point data of this splatteroo. Okay,
yes,
so that should work.
that hasn't yet made the way to build, but it's supported.
Sorry, you're saying this will work?
Yes.
Okay, and right now, if I say geoposition of this, it will work.
If it's a list of geopositions, yes. Mm-hmm.
Okay, so now I take that object and I say geographics of this. Is that correct?
No, because you didn't specify the graphic primitive. So and also for the build, we don't have the support.
There are multiple problems here. There are multiple problems. Why is this a syntax error? That's a question for Brett.
It is not a syntax error. It's an unknown primitive, and that's how the front end.
Why isn't it pinking?
It probably is, but it's
the pink is not visible.
Yeah, it's hidden in some way.
And I thought we were updating the design of these yellow boxes. We went through that like a year ago. Did that not happen?
Completely wrong group of people, I'm guessing.
But that would be your team, wouldn't it? But maybe not. Okay, so Andrea, that's something for you, please, to chase down. Talk to Path about it.
Okay.
Okay. You understood what I was talking about there, yes?
Yes, and I also can go
Are you
to
sure?
the.
You sure? Are you sure? Are you sure? Well, okay, you can quote from the live stream recording.
Yes.
So this will be supported, but it's not supported yet. So these will produce a map of the area given by the points and the region.
Okay, with the points indicated by whatever the default point indication is from a geographics, right?
So our idea was to follow what we do in other cases, which is you would have to say point, I mean, spatial.
So if you do geographics of that geo position, it would behave the same.
I understand. So you're saying, okay, so if I have geographics of that geoposition, it won't actually have points, right? Yeah, I get what you're saying. Yeah, geographics of point of that geoposition will have points. Right. Great. Okay.
And if you don't have the point, then you get the same region of the Earth shown, just no points.
I get it. It's correct. Okay, so average number of points per area is the next thing. So what we're saying here.
So the name is mean point intensity. I should have changed this. The review notebook.
Okay, so it's mean point intensity.
Yeah.
Now this word intensity.
Mm-hmm.
Why is it intensity, not density?
We introduced it in all of our statistics functions, like histogram and smooth histogram and all of those guys. And as opposed to the densities that we also have there. And the intensities have the unit of events per length.
They're counts, not probabilities.
Yeah, that counts per area, counts per length, counts per area, counts per volume.
So it's not a PDF, it's a count. It's not a normalized PDF.
Exactly. So in that context, it's no longer a density per se, because in that world, densities are normalized. I know that they're not in all other worlds, but
I think it's too weird here.
Why?
Because I don't think, I mean, this is a density. It's the density of cities per square mile. It's not the intensity of cities. I mean, it's like you know, there's an intense invasion of alien spacecraft or something, and they are, you know, in this amount per square mile might be intensity, but I don't think otherwise this is a density, isn't it? I mean, I don't see why this fails to be a density.
Well, not in a mathematical sense. I think that's where the argument goes. And so, like when we think in terms of, you know, normal English usage of humans, you think density because it's dense, populated. You have density, and so hence we have intensity. So we are not introducing some, you know, not have the clash of concepts.
Okay, but I don't think intensity is the right name. I don't know whether density is the right name, but I don't think intensity is the right name. What is it? I mean, what really is this? What mathematically is it?
It's an intensity?
No, I've never heard of an intensity. Well, in functional analysis, is there a concept of intensity? I've never heard of it.
So if a density, you integrate it of the region and you get
well aware
one.
You get one. I know.
And this one you'll get n cities.
I want to know when people use the word intensity, other than in optics, which is something completely different, for this concept of the not normalized to one thing. Is that a known terminology, or is that something we're inventing?
No, it's in the spatial literature.
No, not spatial statistics literature. I'm talking about elsewhere. Okay. In the case of a histogram, for example, the counts per, you know, when you're talking about absolute counts per unit length, basically, per unit, you know, value of the whatever you call it. What do you call the thing, the values in the x-axis on a histogram?
Length.
Okay. All right. So then.
But that corresponds to the intensity setting in the histogram.
I know. I'm
So
asking you, what is the mathematical name for counts per unit length in a histogram? Because I've never heard the term intensity. I mean, maybe in
I
physics
was
or
gonna say you
something.
have, because we added it to histogram in like version 8.
Well, okay. I'd forgotten it already. Wait a minute.
Yes.
That's not what histogram just has the notion of counts, right?
No,
No, I
go
mean
there.
histogram has like a half dozen.
I know it does.
Yeah.
I know it does.
Right, and one of them is intensity.
I bet I've never understood that. I mean, I use histogram all the time.
But you've
Look at
never
this.
used the
Here, look at
intensity,
this.
you know,
Look at
settings
this
for it.
crazy thing. Do you see these crazy waves that it's
Yes.
generating? It's like a jellyfish with doing its swimming or something.
Except jellyfish are like slow and graceful about it, whereas
Okay. Okay.
right. So at the bottom of the thing there.
All right. I admit I barely noticed this. Let's see. So someone is commenting here, frequency. Is that what it is? It's not frequency. And Sandra is pointing us to the Wikipedia article on number density. Yeah, well, that's what this is. It's the number density.
I've never heard that.
Well, it's a common term in physics, usually denoted lowercase n or sometimes lowercase f in statistical mechanics. Well, okay, so let's go back to what we're doing here. Okay, so we've got I have to say, oh gosh, okay, let's argue against point density. Okay, mean point density is a number.
Yes.
Point density is a function, but why isn't it called point density function? Because it is a function. It's not otherwise I would expect it to be the point density, which is more like the mean point density.
Yeah, I don't know. Can we get them evaluated at a point too? And then when you skip that argument, it gives a function return.
I think so. I don't see why we shouldn't be able to do that.
So then it follows that what we've done with many other things. When we curry it, when we make it shorter, it has to return a whole function instead.
I think that's right. I mean, I think that's like what we do for nearest, for example.
Mm-hmm.
Gosha, do you get that? I mean, so then the idea would be, okay, so we've got mean point. I strongly think it should be called mean point density, but we'll argue about that in a second. Yeah, I mean, I think it's the right term, but okay. So then we would say point density function, and it would take data.
I mean, right now that's the return value. So what I was saying is point density data comma number gives a number.
That's fine.
Yeah, exactly.
And then point density data without that second thing, just like nearest.
Returns the function.
Right. But now the only thing that's a little confusing here is with nearest, for example, what we get is a nearest function.
Yeah. So here you will get a point density function.
But then you're putting in a point density function. You're getting
no, but that's what I say you shouldn't do.
Well, that's why we have the just point intensity and histogram point intensity.
Because they all return point. All of these estimators return point intensity function.
Yes.
Whatever the estimation method is.
This intensity name is just wrong. I don't know whether density is right, but intensity is wrong.
Yeah, but that's the idea that 3 of them compute and they return the point intensity function, which you can then operate and, you know, plot and such.
What's our analogy for that? So point density, so nearest, I see. So
that's one of the analogies is the data distribution, for example, which is returned from different distributions. And like smooth kernel distribution gives you the data distribution of the given type. And we have empirical distribution, histogram, and so on.
yes. I really like density and I really don't like intensity. And just argue again for me, why is density wrong?
Because it doesn't integrate to 1. So per definition, this is not density. That's the main argument. And all the
How would you
literature
get
there
okay, so wait a
uses intensity for that matter. So you're they're pushing against all the expert all the expert kind of area in a way that they just use intensity, not to be confused with the density,
but
not to expect.
Do they have a notion of density? Do they have a notion?
Yes. If you can normalize that, you know, that then it, you know.
Well, can you normalize it?
Doesn't make sense for this purposes.
Okay, so then it doesn't make sense. So then why are they not calling it? I mean, okay, you know, if you can, okay, and the reason it doesn't make sense is because you would otherwise what is this? This is, no, it's the wrong way around. Look, a PDF, okay, the mean in a PDF, right, is the integral of P of X times X dx, right, normalized by P of X, right? But what you've got here, when you say mean point intensity, that's a different thing. That's asking, it's the number of points per unit area. Okay, I'm going to ask for support from like, you know,
when you integrate, when you integrate this over the region, then you get the total number of points. That's what we care about. I think that so this is going in the sense of the number of points.
Okay, I understand. So your point is the mean point blank, when integrated over the volume, you're saying gives you the number of points.
Yes.
So a mean, oh, I'm very confused. Hey, Jose, do you understand? Can you give me a physics analogy to this?
As a physicist myself, I am with you that this is more density than intensity, because to us, intensity immediately reflects luminous intensity, density with respect to angles, not with respect to volume.
I think luminous intensity is probably from the same origin, because you have the number of photons per per area.
Yes, it is, and that's what they're trying to riff on in calling this intensity, I think.
Yeah.
But explain to me, the thing I'm very confused by is this mean is, I mean, is this number equal to the number of points divided by the area? Mean point intensity is number of points divided by area. Is that correct?
Yeah.
Okay. God, I hate this name intensity. It's just, okay, what other words can we think of here? Okay, so the issue is point density, you claim, when we multiply by the area, instead of getting 1, which is what you think we should get for density, we get the number of points.
Mm-hmm.
So, you know, this reminds me of kind of the latent heat versus, or the heat capacity versus the specific heat. And I suspect that there's an analogy, you know, density of a material is not hell, again, you know, it's mass per unit volume. And you see, that's a great example of a density where, you know, it's mass per unit volume, right? So you multiply it by the volume, you don't get 1, you get the mass.
Sure.
Which is the direct analog of this situation, where you multiply up by the area and you get the you know, the number of cities or whatever, not 1. Hmm. Yeah, actually, Pushax is pointing out on our live stream that this thing is actually equal to the mean point volume or mean point area, right? This is the no, it isn't. No, it isn't, because it's got the wrong units. Never mind. Forget that. Sorry. Personally, I support mean point density, and I'd like to understand, again, the analogy that I would give is density of a material, which does not normalize to 1.
That's correct.
Right, but how to put it? You see, material, it's a continuous object. What we're talking here are events. So if you said, for example, lightning, you have to say intense lightning, because you have lots of lightning per unit area, so your intensity is high.
No, it's a good try. That's a good try. That's really, you're just trying to use something which is intense as a way to,
because you know, in the language we use interchangeably sometimes. You know, when you go to the forest,
intensity and density are used interchangeably. To be honest, that's what I've seen.
And so mathematically, we want to distinguish, you know, what you expect when you integrate. And therefore, we don't call it density because we do not get 1. So we call it intensity because we get something different than 1, which is the number of points. But intensity
says the wrong thing. I mean, that's the problem.
That doesn't. I mean, one can go with density too, maybe. I don't know exactly what the consequences are for the rest of the
I would like to try it. Let's work through what the consequences are. Okay, let's look at these other things here. So this would be point density, which I understand very well. That makes a lot of sense to me. Point intensity is like each point. When I see point intensity, I'm thinking these are glowing points of various kinds of intensities. Point density tells me something about, you know, it's points per unit, whatever. So, okay, so the other things we have, what is histogram point density?
So all of these are, histogram is when you use a bin to create smoothing. It's aggregation. You know what a histogram is, spatial ones. And then smooth, it's these are non-parametric kernel density estimators of the intensity.
Right. So every city has a Gaussian around it. It's the okay, fine. Sorry, what was the histogram one is what again? For the cities, what do you put around?
It's using bins. It's using bins
arranged.
Well, you can specify them. There's like a whole language to specify the bins.
So you start with the bins, and then you collect points to the bins. In the point intensity, you start with the points and you create the bins based on the point locations. And here you say, I want to bin my region in that way. Use this shape.
So there's a bin spec there.
Yes.
Yes.
And so really that just changes the area computation? Or is there something beyond that?
No, it changes the smoothing.
Yeah, so, exactly. Because otherwise, right.
So the bigger, the extreme case is you only have one bin.
Right.
You know, then you only have one value.
So this is analogous to geohistogram. What is the, explain to me how this fits in with geohistogram.
It fits perfectly well with geohistogram, except it gives a function out that you can evaluate.
And it trims.
And it also works in 3D and so on.
Okay, so I've got a question. So what is the analog for a histogram of what function do I get out? It's one of the empirical distribution functions, right? Empirical distribution is basically the thing that is the histogram function.
No, histogram distribution is.
I see.
Empirical makes, it's an extreme and varying bin-sized thing. It's where every point is sort of its own delimiter.
Okay,
So it's about
fine.
as finely resolved as you can get.
Okay, but so the analog here is this is histogram distribution.
Yes.
And let me understand something else. The various distributions that we have, the multivariate distributions and so on, how do they relate to spatial point data?
Okay, interesting in various ways. So if you're okay, so you can always generate a you can have what's called inhomogeneous Poisson point process, and they can take a distribution, and so you can use a distribution to now generate spatial point data following that distribution, and it works for
you mean the point intensity,
right?
Point
The way
function.
one thing with those point collections have is that they're basically, the points are viewed as independent of each other. They don't talk to each other. Okay.
No, I
there
get
are
it.
other models of data where points sort of talk to each other. They don't want to get too close to each other.
So one naive thing that I might want is something where I have a distribution where I give you a random distribution, I don't know, a Weibull distribution or something, and I say, make me throw down points so that their point density function will be that distribution. Is that right?
Sort of. I mean, so we have various ways in which you can use distributions in generating point.
No, but the thing I just said, I don't think is completely stupid, because I mean that's basically.
I mean, so what you can do with that, for example, is to create clusters that would have viable radial distribution. So the distance from the cluster center will be viable. But the point is that viable is one-dimensional. Right? Yes, univariate. So
no, I'm fine with that, but I'm saying, let's say my trees. Let's say I have trees and I want, the seedlings grow in such a way that there's a certain distribution there's a certain distribution of local densities of trees.
So we have a constructor for just that.
Okay.
Scroll down.
Is what?
The inhomogeneous Poisson point process.
No, in this case, what you would want from that description would be cluster point processes. Go down farther.
Oh yeah, yeah. I mean, in general, that's homogeneous. But if you know that your seedlings come from a center, that's gonna be the cluster processes. Yes.
Exactly. So that would be name and Scott, what you can do.
Okay, so this is then. So what I would do, I would feed into this name and Scott thing, my sort of seedling survival distribution thingy or whatever it is. So this is the general case. But wait a minute, why is this mu and lambda here?
Mu is the intensity per se of the centers for the clusters, and lambda is the average number of points in the cluster. This is the kind of the way that it's generated.
But what about the thing I'm asking? Let's say I'm planting giant trees, some kind of geoengineering project. I'm planting giant trees across the US, and I want them with a certain, average density. How would I get that?
Then you use the inhomogeneous Poisson point process, because that gives you then you can put the distribution, like the intensity, all over your region where you want to put your trees. What the cluster is doing, it's really creating the next generation from the clusters, like the centers from the parent, let's say, process. So this is that you have the parent, which is distributed as a Poisson point process, and then you create the offsprings of this parent around, which are the clusters. That's the control that you have here. And the way that to put the parents, so your original trees, into the region, then if you know this is uniform, you use Poisson point process. If you know that it's not uniform and you want to specify your intensity functions, then you use the inhomogeneous Poisson point process.
Okay. Okay, so let's say we replace the word intensity here with density. Does this make a nonsense of this? Don't think it does.
Well, the point is that mu here stands for the mean number of like the mean point intensity, right? If it's a number, that's going to be the
known as mean point density,
right?
where density is
Density.
interpreted.
Right. I mean, I am struggling with the fact that the things has to integrate to one, and then like everything will have to be rescaled. So like I'm trying to kind of compensate for that. In this vision, this is the world of densities. So.
Right. I mean, Brian on our live stream is saying it boils down to who will use this most, statisticians or non-statisticians. Yeah. Right. Right. That's the. I mean, this is the challenge. A lot of terminology in statistics is sufficiently unfriendly to the outside world, so to speak, that it either doesn't get used or it gets used only as an incantation by people who don't understand what it means.
So you have to keep in mind first that there's massive simplification that we have affected for this, first of all.
Good. I'm glad to hear it.
This is a 2000 function package.
Yes, I get it. Yeah, right. I'm not surprised. Well done. I mean, I'm not even going to ask what all the crazy stuff that all right. So okay. So then okay, let's look at this random point configuration. So random point is something that selects a single random point in a region, right? What this is doing now.
No, the random point can generate single point, but you can give to random point, you can give a number of points you want in the region, and it simulates the points which are uniformly and independently from each other distributed.
Exactly. Right.
So here, what it differs here, it's that you can give a process, the point process. So you want
to
specify this in a different way, and hence the configuration, because you place the points according to certain scheme, which is the intensity function.
In this case, I don't have an objection to the word configuration. I don't think. I don't know what else we call it.
Because we can't call it pattern, right? So this is called random point patterns in the literature. And since pattern was taken,
I think this is an okay name for this. Let me understand what the arguments actually are. So the first thing is a point process, you're saying. So default values, wait a minute, where are some names for processes that I can use here?
Go down to the examples. There's like a whole guide page of them. But we can look at some of the examples.
Poisson point process is the most common. This is where you got the uniform distribution.
It's the least interesting in a way.
Well,
okay.
It's the gold
There's
standard.
There's a whole field of cosmology that looks at the world as, like the whole big problem to resolve is whether we uniformly distribute
yes, yeah.
galaxies or not.
Yes. I know. I used to know people who did that for a living. In fact, including some of the ones who originated the whole modern star counts.
Right.
So what I want to say that if you now generate the configuration for the Poisson point process, you get the number of points automatically because that follows Poisson distribution. So here the difference is that you do not give specific number of points because this is random.
What are those parameters, 10 and 2 in the Poisson
This is the mean, the mu is the mean point intensity in the Poisson point process, and 2 is the dimension in which we are working. Because you need to specify.
So let me just try to understand. So the 10 in this case would be basically, what the heck is that? Spatial point.
Sorry, that's the
prototype.
That's a prototype. That's
no problem.
Yeah.
Okay. So that's not needed anymore.
No.
I need to go and update the the documentation. So,
no problem.
But, yeah.
Okay. All right. Okay. So here. That number 10, if I were to explain that is the density of points in the region, that doesn't sound wrong to me. That's the number of points per unit area, right?
Mhm.
Yes.
That's a frigging density. I'm sorry. Okay. Okay. But so it's
And,
in
and
this,
if the 2 was a 3, that would be the number of points per unit.
yeah,
Volume.
in volume, per unit volume, right? And so just to understand this case, right? So just to do this case here, and now I'm going to say, what can I say? Just say list plot of this, right?
Sure.
That's
What?
not gonna work in the prototype build yet. So what you can do is to use the points accessor for that. Sorry, I had to we had a collision with the branches. So to have the
Oh,
build running properly, the support has been disabled.
That's the problem is that
Yeah.
your trees, you had a collision with the branches because of radial distribution function. Anyway, never mind. Okay. So, okay, hold on. I just want to understand something here because I'm a little bit confused by one thing here. Okay, so why am I not getting per unit area here? Let's forget this disk. Let me use a rectangle here. Okay. Why am I not getting on the order of 10 points there? Why am I getting a lot more than 10 points?
You got 11 points. That's what the lighted form tells you. Number of points 11.
Oh, I see. Okay, so I'm just bad at estimating these things. Fine.
This
Okay,
is not
all
the
right.
exact number that you're gonna get. It's the expected number.
I see. Okay,
It's a random
fine.
variable. That's
Yeah,
what
okay,
you have
fine.
here. Mhm.
Fine. Okay, that's fine. All right. Okay, cool. So then if I want, again, to me, as a naive user of this, the most common thing I'd want is the radial distribution function to have some form. And you say I get that using this inhomogeneous Poisson point process. That sounds extremely obscure.
no. Go back to the processes if you want to.
Okay.
I mean, by the way, if you want to understand what the radial distribution function, that's a part of descriptive statistics you didn't look at yet.
Yeah.
This is pair correlation function, for example.
Well, I would say Ripley K.
For God's sake, we can't call it. If that's the radial distribution function, it should not be called Ripley K. The radial distribution function is a well-known concept in many fields. Right?
But this is what it's called in the
In
spatial.
some weird
That's
piece of
the
the literature.
okay.
Okay, but in every other field, it's called a radial distribution function.
But it's not the function. You get the number. Well, actually, maybe if it's function of the radius, that's what you're saying in that way.
What I'm saying is,
But
what I'm
again,
saying is,
you're not getting a density here. Just want to point out, it's the expected number, so you're gonna get again the something.
okay, fine.
Not the
But
distribution.
the radial
wise.
distribution function should be the probability to get, what is the radial distribution?
Well, that's pair. If you're talking about probability, the pair correlation is the probability density of finding 2 points within distance r apart.
Mhm.
Maybe that's what you're looking for.
And also the nearest neighbor G and empty space F are probabilities for different events. So they are actually CDF.
Okay, so if I say nearest neighbor G, I'm looking for the function which tells me, as a function of oh great, just make sure that nearest neighbor graph comes before nearest neighbor G in this autocompleter. Can Andrea, that's something for you, please?
Will you repeat again, please?
I'm sorry?
I was going to say at that particular state,
135.
Stephen,
Yeah, go ahead.
it's running into the autocompleter putting exact matches at the top. So the question is, what's the completion when you don't have the G there?
Correct.
Nice.
I think you should point out the suffix. I mean, this is a rare case of a weird suffix in autocompletion. Do you see what
I
I'm
run
saying?
into this all the time trying to type normal distribution.
Actually, I've never noticed this case. I can see that when the probability is sufficiently weighted towards the non, I don't think this is correct what it's doing here. I don't think it should do this. I think that the probability that you're trying to type, this is a prefix of nearest neighbor graph is so much higher than that this is intended to be nearest neighbor G. I don't think I've noticed this case before. This is something that we should feed to the user assistance folk. Can we do that? Do I need to do that?
I can send that one to them.
Okay.
You should try typing normal distribution. It's lots of fun.
Okay. Well, I think I have noticed that, but I didn't internalize what was going on. Okay, normal D is okay. It's
Right. I mean, but like in the process of getting there, it's like
Yeah,
norm,
Yes.
and there's just a different one always at the top because it keeps
Right.
exact
Okay,
matching.
so listen. I want to make the radial distribution function, which is I want to plot, given that I'm at a particular point here, what is the density of points going out from that point? How do I get that function?
Oh, that we don't have for a particular point in space.
We should.
So these
Radial
these
distribution function.
these have statistical meaning here. So there are two concepts going around here. One is from what's called a typical point, which means from any of the point in the point collections,
Mhm.
Regardless of which one you pick, that's the distribution you're going to see, whatever one of those functions. The other one is from a generic, what do we call it?
Location.
For location, which means any point in the region that you gave, but not, which with probability 1 is not going to be one of the existing points.
And you can imagine this when talking about tornadoes. You're not talking about the distance between tornadoes. You are interested how many tornadoes from my location, within some radius.
Yeah, or from any location is what these things give you.
Okay, all right. But I believe, unless I'm completely confused, that in statistical mechanics and in endless studies of stars, et cetera, that the radial distribution function is a thing of significance. That is, starting from a point, what's the probability to find another point?
So you give the point from which you start.
No, you don't give it. You're simply asking averaged over all points.
Oh,
So
yeah, but that is what we were doing. Then I misunderstood what you said.
Nearest neighbor G gives you that. This is the
Okay,
probability
fine.
of
Okay.
finding a point within a distance R from
Okay.
any point in your data.
Okay, so if I say this,
So that's the
and then
nearest
I say
neighbor. Yeah.
nearest
So-
neighbor G.
Don't look it up. That doesn't look. Because that will be a very inefficient way of doing it.
Right. So can you close the square bracket after the first argument and then apply to R? Ah.
There's something weird. There's something. What's 36?
Oh, because 36
Oh,
is a
it's 36.
graphics.
Oh, graphics.
Not
Okay,
the
so I
special
want to
point
know
data.
the point data. Okay. What the heck? Oh, and maybe maybe the distance is.
Distance
Oh, I see.
is, yes. So you want to go smaller.
Oh, very nice.
Mhm.
Okay, so this is the probability to find a point within that shell.
Yes, and you see that it's cumulative. This is the cumulative distribution function because, of course, when you increase R, you have a larger probability. This includes everything.
All right.
that
Okay.
was
I
before.
think the radial distribution function is not cumulative. That is, it is the derivative of this.
But
That-
it makes, well, if you differentiate that, then you get some PDF. But this is, I mean, the idea is that when you radially look around, if you increase your radius, it includes all the points that were already there. So this concept, it has to be cumulative.
Okay. So Sandra has commented in fluid dynamics. It's frequently called RDF, the radial distribution function. So there is a concept of what we're talking about here. So let's just figure out what it is. And it's a concept people need. Okay. Yeah, let's look at the Wikipedia page. Radial, there it is. Beautiful. Radial distribution function for Liner-Jones model.
Pair correlation function. Well, we have it. It's called pair correlation G. Yeah,
Yep.
that's the
Okay.
derivative. That's
Yep.
in shell.
Yeah.
Exactly.
Okay.
Yeah.
We have that illustration.
Hmm Exactly.
Okay.
So
Good. I'm pleased.
So then there would be good to have one of those also known as statements, right?
Mm-hmm. Yeah,
Yes.
I'm making notes.
Okay, why is this taking forever?
I think it's because it's optimized to.
I think
you
if you
optimize to
evaluate that,
pre-compute the
if you evaluate that input argument before, so plot has this. If that's going to evaluate every time you get a new R.
Yeah, it's a heavy evaluation load.
It has to be outside the R.
Doesn't have to.
I mean, otherwise evaluate doesn't do anything.
Yeah, okay.
okay.
You were right. That was the issue.
Mm-hmm.
Now, why does this ploop out after 0.4?
Probably don't have any.
I mean, what's pair correlation G %35 of 0.5 or 0.6 or something?
Yeah.
It's probably like a missing or none or something, or
Or
unevaluated
indeterminate.
or.
Indeterminate.
Is that the right thing? Okay, pair correlation. That's saying above that distance. What does that mean? And why does this thing give up there as well?
No, it's just constant one. It doesn't give up. So logically, if you count all the points, then probability of if you are within a certain radius and all the points of your data set are within this radius, then probability of finding a point is 1, and hence you can say that it's flat. It flattens out.
Okay,
it's like
but
the CDF
the probability of finding a point at a greater distance is just 0, isn't it? Why isn't the pair correlation 0?
No, because one is cumulative and one is not. So the point is, if you nearest neighbor G, if you go, in a larger radius, you encapsulate all the points. So you have, for sure, you're gonna find the neighbor. And the pair correlation, it's not a cumulative object.
I understand, but why is that saying indeterminate? Why isn't that saying 1 when it's outside the region? Because you found every point.
I think there is no data.
No, I was going to say, if it's actually accumulating the pair correlations or something, then the indeterminates could be corrupting.
Yes. And so that goes to something which we call max radius, the property, and
But I don't understand.
That makes sense.
What makes sense? Hold on. Gosha, what are you saying makes sense or doesn't make sense? Are you defending the fact that it should be indeterminate? In which case, I need to understand why.
Right. Well, what I'm trying to, what I'm just thinking, because whether it is reasonable to look, for the points at that distance.
I don't think one could say 0 because we don't know anything outside of the region.
I see what you're saying.
Yeah.
You're saying, okay, so let me characterize what you're saying. So you're saying, given an observation region, as you're calling it, if you ask for a nearest neighbor function that goes outside the region, it's like, well, we just don't know. So indeterminate is correct.
Mm-hmm.
But, okay. Right, but that's something you don't have in a data distribution. Do you have something in like an empirical distribution, which gives you the range of, do you have an analog of observation region for empirical distribution?
Domain.
Which, by the way, will be a much better name than observation region.
Oh, if you had Adam here, you would have a big argument.
Yeah.
Sander is saying that he thinks it should go to 0. This pair correlation function. But I think the argument for if you just don't know it, you just don't know it, is not unreasonable. I mean, don't we have some missing? Should it be indeterminate or should it say missing? Maybe it'd be better to say missing.
I think we're better in handling indeterminates than missing in the system. I think missing is.
We have missing stuff for missing.
Well, but the missing kind of indicates that you know how to maybe compute, but you don't. and indeterminate maybe indicates in the way that you cannot compute. So, like, I mean, somehow for me, the missing means that, you know, that it's not available now, but it might be somewhere. And indeterminate means that no matter how hard you try, you will not compute that, and hence indeterminate. So somehow for me, that's the logic in favor of indeterminate.
Sorry, I was just sending Christopher a note commenting that confirm I don't think triggers on indeterminate, and it probably should. Right? Does it? Let's see. No, it doesn't. On the other hand, if I say, right. Okay.
And I think failure and dollar failed and whatever are a much stronger statement than indeterminate.
Oh, absolutely. But it's a question of what the default. I mean, you can always give with confirm match. You can always give an explicit list of things to trigger on. It's a question of what the default behavior for confirm would be, because confirm does trigger on missing.
Right.
So I think it should trigger on indeterminate. I don't see an argument for why it shouldn't. Okay, we are really messing up our timing here, and I know that we have I mean, we're definitely not finished with this process.
No, I expected us to have at least. Now I'm kind of thinking 2 more, but
I think we might be able to nail it in 1 more. But I think this is very nice functionality, very nice, very interesting functionality. I actually had no idea this was such a rich area.
Oh, yeah. It's a big rabbit hole.
Right. But I think it's a rabbit hole too important to be left to the spatial statistics aficionados.
Should be left to the statistical mechanics aficionados.
Well, right. That's a different. It's a different collection.
Collection or configuration?
Right.
Oh, thank you. Thank you.
You know, there are some angular measures which I invented at one point in the long distant past that get called Fox-Wolfram variables that are used to characterize. They're basically things to do with spherical harmonics that characterize. I mean, you can think about them this way, at least. They characterize the angular distributions of configurations of things. I hadn't thought about those in a long time. Anyway, okay. It's probably so what those are for is characterizing. If you have one of these things and it's in the shape of a, you know, is it ellipsoidal, is it circular, is it whatever? You understand what I'm saying? So it's a way of characterizing in a independent.
Oh, I see. You're talking about those angular measures.
Yes.
Mm-hmm.
So I guess this is what the I don't know if it is the same, but what's the Frye plot is trying to
I have no idea. I've never heard of a Frye plot.
It's when
maybe
you take
maybe that's a rediscovery of the same thing.
When you take the vector differences, right? When you have a elongated region, they're gonna look differently than when you have a round region, because they're gonna be aligning more.
No, I understand the things that these things that got called Fox-Wolfram variables, which I had nicknamed at one point the 3 animal variables, were you know, their idea. I mean, they're used by particle physics people, but I mean, their idea is you take let's see, what do? You take the spherical harmonics or the generalization in d dimensions. You take this of theta phi. Well, actually, we can do the case with you can do it just with sines and cosines. So I think it's just sine n theta, and you take the sum of those over the actual points, over the actual values of theta for which there are points. You see what I'm saying? And I mean, I think that the thing here is, given a center, right? Given a central position, you're simply looking at the number of points in each direction away from there, And then this is characterizing basically whether that distribution of points as a function of n, you get this thing as a function of n. And for example, I remember H2 is a good characterization of whether the thing is kind of just elongated or whether it's sprouted out another edge to it. Okay, let's see. Okay.
I think that we should hold here though for today. I think and then we schedule another one.
Fine. Preferably before too long, because otherwise I'm going to.
Yeah, no, I agree. We need to have it soon.
Right, but see if you can, work through the things that we've already talked about here. So next time we're starting from that point. Fair?
Okay. Yeah.
And yeah. Okay. We've now missed another meeting, which was, I just want to know at least what it was about. Where's the at least let's just see the agenda just so I know what we missed. Where was that agenda?
It's in the calendar.
No, for the other meeting.
Yeah, for the other design review, or?
Yeah, for the other design review, the geography.
Should also be in the calendar if they follow.
But they
follow the rules.
It's not.
Sorry, that's your team. I'll send it to you.
Well, I don't know why it's not. Maybe somebody can say, is Jose, do you know where the agenda is?
I have it. Okay. It's in my collection. I sent it to them and I asked them to put it in there and they didn't.
Oh, wait a minute. No. It is incorrect. It is in fact here. I just want to see what this is about, roughly. Oh, wow. Vector geographics. That's exciting. That's super exciting. Really? You've managed to make this work?
Well, these are partial examples of how you will handle labels. We have, I can send you examples of actual maps. Let me send you a notebook.
That's really exciting. So you mean you've managed to get the vector geographics working now?
Yes, in a state that we consider it experimental, but we have several styles. We can handle labels correctly, and yeah, it's working pretty well. You'll see in the notebook I just sent you.
Okay.
Do you want to go on with that meeting now, Stephen?
We probably shouldn't. But oh, this is beautiful.
This is one of our styles.
But it's so crisp. Thank goodness we finally have this. Oh, that's so great. Why is it experimental? How do we get it out of being experimental?
Well, the problem is that there are so incredibly many details here that we are finalizing some of them right now. And so we are a bit concerned with having this as the default. But certainly people should opt in by just specifying the background they want, background style. And we have a collection of them.
Oh, can we make this package updatable so that we can really roll this out?
It already is. We already have a Geo Backlet, which is being installed. It was installed recently in your machine to play with this. And yep.
Look at this map. This is fantastic. This is so much better than we've ever had before.
Mm-hmm.
How much data is there in these maps? Is this actually, what is the download size?
The first one is about 7 megabytes. I mean, big cities, city centers are heavy. And right now this is a bit slow, but as it happened with the image geographics, we will iterate and make it faster.
Do we understand the flow of why it's slow? I mean, is it transferring bits that's slow, or is it something to do with rendering that's slow?
It's a bit both things, but at the moment, the main bottleneck is the data, the transfer of data. So Francisco has made the tiles in groups to accelerate things. And then there was the discussion of putting everything into the CDN, which is moving on. And that,
Yeah, that we need to have. Right. I'm really excited to see this. This is really crisp and lovely. I mean, especially, I mean, the fact that both the labels are crisp and the features are crisp is really good. But I mean, even just the labels being crisp would be a big improvement.
Right. And now this is all vector, so we can control layers. We can have multiple styles with the same data because the data comes separate from the style.
Right, I understand. But so if I take this and I just go, so you're saying this has the full level of detail of every
we can control that by zoom. And there's a question here. What,
look at that poor tower that fell down. What? Isn't that Notre Dame? Notre Dame?
No, it's Notre Dame is on one of the islands.
This is an island.
It's in the middle. It's yes, in the exactly. That's Notre Dame. You're pointing.
Oh, I didn't. Oh, I looked at it wrong. I didn't see your mouse. Yes.
Right, and that's presumably the tower that fell down.
I don't know why it's that.
What's that?
I don't know the reason why this is not colored.
Well, I assume it's because it collapsed, right? Isn't that the?
No, but it didn't collapse.
It didn't.
Maybe it's some glitch in there.
Maybe it doesn't have its roof there, and so it isn't filled in. So now in the front end, wait a minute, I'm complaining here because I'm not. This scrolling the front end is getting scratchy. So this tile was not I have all of the data then. Every piece of data about the center of Paris is here. Is that correct? In this download that I have?
Yes, this is 7 megabytes of primitives.
And so for example, this cross-hatching, this is our cross-hatching. Is that right?
I guess so.
I think so. I think that's what Francisco's using.
Yeah, we do use our new.
But is it really necessary? Can we not downsample this?
We can. We have now full control on zooms and what to put in each zoom.
Okay. Okay, fine. So then it would be vector graphics, but it might not have, I mean, you know, having every door handle shown on each of these buildings is not going to happen at the zoom level, for example.
Exactly. I mean, one can go deeper than load zoom 14 or whatever, and then you have a lot more detail, but it will be a more expensive graphics and download time.
Right. And look at that. Why is that accented character looks wrong there?
Yes, we know that has been reported.
So another question is, given that this is all vector graphics, can I select? Is there any way I can select this text?
You can triple. It's yeah.
Oh my God! Really? That really works?
Yeah, you can move that
until we disable it. Which,
okay.
I mean, I think is one of the things that we were discussing recently is that by default you probably shouldn't be able to select general map elements.
Wait a minute, this didn't work. I tried pasting from this.
Oh, it's probably white text on a white background.
Oh. So you're saying if I go here,
And
oh, I see. So there's a graphics piece of, no, there we go. So there it is. Wow. So if I can select map elements, that means I can actually edit this map.
What do you mean?
Oh my God. They really are vector graphics.
Everything is vector here. I think.
But why did it select only those pieces?
It looks like they've organized graphics groups or
yeah, this is
grouping.
weird.
You know, I would guess that it's polygons, you know, grouped by number of vertices for efficiency purposes.
Yes, we have grouped lines, for example. So there is also the having things together so that they project faster.
Oh, I see. Yeah, okay, so this is pretty crazy. This selection is crazy. I mean, while it's amusing to light up pieces of Paris here, I think this selection is crazy. Okay.
Right. So here we had to handle multiple things, including labels and separation between labels and styles. There is also ongoing work on improving all the styles. And we have to
This is really important. This is really nice and really important. But by the way, you did notice my complaint about the front end scroll speed now.
Yes, yes. In general, we have seen that graphics behaves quite well. I mean, I have downloaded even cases with hundreds of megabytes of data, and it was with time was able to show it. But yes, I mean, these maps are heavy load for graphics.
Is this going to work, what I'm doing here?
I expect it to be bitmapped, and probably does look, you know, poor, but
Not terrible. That's really
not
not
too bad,
terrible.
no.
I mean, these got bitmapped as you expected, and some of them didn't render perfectly, but it's not embarrassing.
Mm-hmm. Yeah, I mean, the hatching came across the worst of anything, I think. At least over Zoom, but
Yeah, it's anti-LS too. Cool. Okay. I'm going to make a comment actually about this, the way this publishing thing works. I realized we need something here where I can get, I don't understand why I can't get the purely published version, as opposed to, let's see, the purely published version, which is not what, as I would see it. Or maybe I did get that. I did, that's the OBJ thing. Never mind, silly message. Okay. There's a question about, do we have map styles implemented? We are working on map styles. That was, yes, that is one of these. Why not cache it as a bitmap? Yes, this is, yes. We don't need to cache this as a bitmap because we can render fast enough at a given tile resolution.
Right, and this is tile, so we do cache the
Right, so now the question is, how do we feed this into spatial statistics? So let's say I take the buildings in Paris.
that's another hour-long meeting, probably.
Yes, that cannot be done right now. So these we get the vector primitives to be drawn. We cannot get something like, give me all the streets.
Right, yet.
Yes, that requires a different service in the GeoServer.
Right. Although we know that that's possible. I mean, like there's samples that, like Christopher had a sample and other people have had samples of, you know, getting the street network and so on.
Right, it will be possible. It's just that we are working very hard on this part of the project first.
Right, I understand. Makes sense. Okay, great. We should wrap up here. So we need to continue this other stuff in a different meeting and several more things to do. And great. And I think I had made some changes here, so I need to push my changes back, right? Roger, you recall? I made changes to these documentation pages, right?
Yes. Yeah.
I will.
And you will run into conflicts, but just push.
My system. Yeah, my
resolve.
system auto pushes, so it unfortunately.
I am prepared for that. So.
Okay,
fine,
terrific.
Be cool.
Okay, Great. All right. Thanks, guys. Great stuff. To be continued. Thanks to folks on the live stream. See you all. Actually, I'm going to see if you join. There's a later live stream about form notebooks in a little bit less than an hour. So join it. Check out what form notebooks are. I don't think we've live streamed about those at all yet. A new and exciting thing that's coming.